So first of all, I'd like to welcome you to the OpenCRVS webinar. Really exciting moment for us. And I just hope at the beginning of this call that you and all your families are very safe and locked away where necessary in these times of COVID-19. It's all very worrying. And thanks for taking the time to join this call. We've got a few core team members on this call. For those who don't know me, my name is Edward Duffus. I am the head of innovation at Plan International and the product manager of OpenCRVS. Anina?
Yes, thanks very much. Good morning, everyone, or good afternoon to those of you around the world. My name is Anina Werson, and I'm the OpenCRVS product owner and implementation lead. Really excited to share what we've got today.
Super. We also have Ewan Miller with us.
Good morning, everyone. My name is Ewan Miller. I'm the OpenCRVS technical architect. Nice to meet you all.
Excellent. And the fourth team member, I'm not sure whether he's joined the call yet, is Jonathan Pye-Finch, who's our design lead. And certainly you'll see his work throughout this presentation. So you'll have noticed that we're recording this presentation. I hope that's okay for everybody. That's important so we can share that on the website afterwards for those who are not able to join. And we'll be sharing it on the website afterwards. If you have questions, that's fine, and you can go on. If you have questions throughout this presentation, I'd request that you put the question into the chat box. I'm expecting quite a lot of questions, and we'll try and get to as many of those as we can at the end of the presentation. And if we can't, we'll get back to you shortly after the presentation. Make sure you get the answers to the questions you have. Super. So on the agenda for today, we have a quick recap of what OpenCRVS is, for those who it's not for the first time they're seeing it. We're going to explain a little bit the journey of OpenCRVS and how we got to this current point and the exciting point we actually have reached. We're going to then take you through some of the product capabilities and features that we're really excited about, and then dive into the technical approach, the smart technical architecture approach which underpins OpenCRVS and makes it so powerful. To bring it to life, then we will share briefly some reference implementations, some of the work which we've been doing with the government of Bangladesh and a proof of concept in Zambia. And then finally, we'll finish up with some work we've been doing on implementation approaches and how countries can get the most out of OpenCRVS. Great question already coming in. Will you get the presentation? Absolutely. So all those people who've been invited, and certainly if you put your name and organization down on the list, we'll make sure you have the full presentation sent out to you. So no need to be writing things down as we go through. Super. Next slide, please, Anina. So for the audience involved today, I'm kind of assuming, obviously, an understanding of the importance of civil registration and vital statistics. We're passionate about the fact of its importance of having a legal identity from birth for all children, and of course the capture of better data on death, mortality statistics, and cause of death. And putting that together and understanding this data to inform better decision making is what makes CRVS so integral and so important. So what we've set out as our mission for OpenCRVS is making it a digital public good to help achieve universal civil registration and evidence-based decision making in all country contexts. If you move on to the next slide, please, Anina. So from the outset, a number of years ago now, we made a certain number of commitments to the OpenCRVS product and how, what we wanted what we wanted it to be. And here are those commitments. And I'm really proud to say that sort of 3 years on, we have a product which complies and enables all of these commitments. And that's what we're going to share with you today. So first up, we wanted to ensure that OpenCRVS involved no license fees, so it was publicly available, and OpenCRVS is not tied to any one specific software vendor. We understood the variability of different country contexts for civil registration, so we wanted to make a configurable product that would fit the needs of all country contexts. We also understood that civil registration should not be seen in isolation. It works together with other government systems. So we wanted to create a product which would be interoperable with other government systems and interoperable in an easy and open way. We wanted to ensure that from a rights-based perspective, civil registration was highly accessible. To achieve universal registration, we wanted to make sure it was highly accessible to ensure inclusion, even in the remotest areas where there's limited or no connectivity. We wanted to ensure that all personal data captured within the civil registration system is kept safe and secure at all times. And we wanted to ensure that OpenCRVS was easy to use, easy to deploy in low resource settings. Even when there's low staff capability, we wanted countries still to be able to use OpenCRVS and get the most out of it. And finally, and ongoing, we want OpenCRVS to enable new models of civil registration, new models such as active registration down at a community level. It's about automated processing to take the burden of civil registration off manual tasks traditionally conducted by members of staff, civil registration staff. And finally, we wanted a new model of civil registration where data dashboards and analytics provided real-time information for civil registration staff and others to better understand their data and act upon it. Next slide, please, Anina. So super, here's just a brief overview of the journey we have come on. As you can see, it goes back to 2016 and actually before. So the two bars at the top in light blue, that's a piece of work which we did prior to OpenCRVS. We ran a number of digital birth registration projects in a number of countries, and a number of you on this call were part of those projects. That's when we started learning a lot about appropriate technologies to support civil registration. We then created some publications, most notably the CRVS Digitization Guidebook, which is a step-by-step guide of how to think about analyzing, designing, and planning for a digitized civil registration system. But then, if you will, we had a bit of a light bulb moment working together with many of you. We understood that existing civil registration systems were just not up to scratch. They were not doing what civil registrars needed them to do. And we really had a reflection at that point that countries needed a high quality civil registration of vital statistics system that would be available to them as a digital public good, a common asset that many countries could use and benefit from all of the promise of digitized civil registration systems. And so then, since that point, back in 2017, we've been on a journey, again, with many of you, thankfully. We've been we went through a prototyping phase where we built an initial version of the product and we shared it with you. For example, at the Conference of Ministers in Mauritania, and we got feedback from you, also with the regional steering group for CRVS in Asia Pacific. That helped us then start work on the core product itself. We established a technical advisory group. We had 2 meetings with the technical advisory group to provide specific feedback on how to create a rights-based civil registration system. And then finally, in the later phases, we've been working on reference implementation. So we've been working for the last couple of years with the government of Bangladesh, a fantastic partner, to first configure OpenCRVS and test it at a field level and continuously improve the product. And now we're in the phase of a full live pilot in Bangladesh, running up until the end of 2020. And in Zambia, we created a proof of concept for the Zambian context. We did that in just 2 to 3 months. And then we shared that at COM5, at the Conference of Ministers in Zambia at the end of last year. And got additional feedback from that in terms of its applicability for the African context. And finally, just the box in green, more recently, unfortunately, we've been reflecting on and creating some guidance for how OpenCRVS could be configured to be resilient in times of COVID-19 or any pandemic. Next slide, please, Anina. Thank you. So we've reached this moment now, which we're really proud of. In January this year, we, as a commitment to the CRVS community, we open sourced the source code for OpenCRVS, and now you can access the code in a public code repository called GitHub. So let's, as that's live, let's have a quick look at this. So the presentation will be provided to you afterwards, so you have all the links. You don't have to write these down. So this, for those who are developers, perhaps, this is GitHub. So this is where the source code is held for OpenCRVS. You'll see the core code repository, and you'll see other configurations, for example, for Zambia, you will also find here. So this is all of the code. And importantly, in the bottom here, where Anina's pausing now, there's full documentation for developers for how to configure, install, deploy the OpenCRVS product. So that's really where we keep all of the technical information about OpenCRVS. So I would encourage anyone with a technical bent or a software developer to go to the GitHub repository. So the second point here is now, we're really proud about the fact that we have fully documented OpenCRVS. So the documentation is available at the link that Anina is clicking, and you'll be able to explore here all of the functionality that OpenCRVS presents. This is just the homepage. So let's click through and see some of the documentation, Anina. Thank you. So let's just pause for a second. This is obviously just an introductory page, but if you look on the left-hand side, you can see the menus, which are really important and shows the full extent of the documentation of the product, which we have done thus far. We have a system overview, and then beneath that, it goes into more detail. Perhaps we should just, so you can see there's a set of design principles by which we've used to create the OpenCRVS product. Then we have the functional architecture. So let's take a quick look at the functional architecture. This provides an overview of the functional components that make up OpenCRVS. So you can see this is divided at the top into the vital events, which it currently supports, currently just live birth and death. In the product backlog, we hope over time to include other vital events. And then in the center, we have the core functions. So obviously those working in civil registration will recognize the key milestones within the civil registration process, from notifying a vital event through to declaration of a vital event, validating and registering it, issuing a certificate, and then the vital statistics export. We then have some other functionality on top of the core process, such as correct record and record verification. Beneath that, there's a set of support functions which are necessary to sort of augment the functionality of the core functions. So there you can see login, for example, performance management to be used by the civil registrar, audit functionality, learning, legacy data import. Really important features, but not part of the core civil registration process. And at the bottom, you can see system administration functions. So these are the specific functions only to be used by the system administrator, such as user and team management, content management, etc. On the right-hand side, you can see, as per the interoperability standards, you can see the external systems which OpenCRVS should be able to interoperate with. Most notably, obviously, health and National Population Register and National ID systems. So the purpose of this presentation obviously is not to go through all of the functionality in great depth. Here we're providing an overview of the documentation, so you can come back and explore it in greater detail. So back to the menu on the left-hand side, you can see sections about some of the key features that OpenCRVS has, details about how OpenCRVS interoperates with other systems. Here you can see National ID, for example, and a section on configuration. And I'll just pause on that for a second, because that's so vitally important. We recognize, of course, that every country context is slightly different. And here you can see what you need to configure OpenCRVS in your country. So we really try to lay out step by step how you go about getting the most out of OpenCRVS. So the next section is user types. So one of the design principles that we followed is trying to be user-centric in everything that we do. And so we spent quite a lot of time exploring the different users that are involved within the civil registration process. So here you can see user types of field agent, registration agent, that would be someone working within a civil registration office, a registrar, a registration manager. All of those roles which we have observed in the field have a role to play. And we describe the work which they do and how OpenCRVS supports that specific functionality. And you can see Anina scrolling down and showing some of the example users, for example, health assistants in Bangladesh. Let's move on. Let's go into core functions. So this is the mainstay of the documentation. And so here, what we do is we have, for each of those core functions of the functional architecture, we have a full description of the functionality. At the top of each description, you have a video, and a video which is a video demo of the functionality actually working based on a configuration, in this case from the Bangladesh context. So let's have a quick listen.
In this scenario, I'm a field agent completing a birth registration application form and sending it for review at the registration office. The same application form is used for a registration agent and registrar working in an office environment. To start, I'm going to click on the plus button here, and I'm going to be asked what type of event I want to declare.
Okay, let's pause there. That's a 7-minute video, so I'd encourage you to go and take a look. And when you watch that video, you'll see end-to-end the process of declaring a vital event within OpenCRVS based on a specific configuration. So as per all of the other core functions, then what we describe is the configuration required for this particular module. So within declare a vital event, obviously the configuration is related to the form fields. So within configuration, you see their birth registration application and death registration application. That's where the section you go to learn more about how you configure for specific form fields for your country context. Again, to follow a very user-centric approach to develop OpenCRVS, here we've included the user stories which we use during the design process to actually create OpenCRVS. So you can understand from this that each user story is actually built out in OpenCRVS currently. So the first one, for example, as a field agent, I want to complete a birth registration application and send it for review so that it can be registered by the registrar. So clearly that's very standard functionality. You'd expect to see that in the product. So there's a full range of the user stories. And then beneath that, we actually have the functionality itself within declare a vital event, as per the video at the top, in a little bit more detail. Obviously, starting an application, how do you get it initiated? How do you enter contact details of the applicant? How you complete an application form? Even the detail of the client-side validation. So how are form fields validated as you enter them as standard? How you attach supporting documents, how that functionality works, how the review of the application works before submission, and then finally submitting the application. So it's really a very detailed step-by-step guide of what you get in the OpenCRVS core product. Super. So you have the same level of detail for all the core functions. Likewise, for the support functions, it works the same. The system admin functions, please go and explore this as well, and you get the same level of description. There's a technology section at the bottom, which gives you an introduction to the technology and describes how you would install and technically configure OpenCRVS for your needs and how you set up the interoperability with other systems. Finally, the tab on the right-hand side, Anina's just clicked on, is community. So if you want to get involved in the developer community around OpenCRVS, here's some information of how you do that. This is joining the community. We have a community on a platform called Gitter, where developers can ask questions and exchange between them. How you can contribute to the OpenCRVS community, some details about the team and joining the team, and some of the implementations we've already worked on, including some videos from Bangladesh and Zambia. So there's a wealth of information, and obviously I'm just skimming over the surface, giving an overview of the documentation which we have created. Finally, on the right-hand side, we're ready now for you to join the OpenCRVS community. Whether you're in the business of civil registration, or whether you're a system integrator, or whether you're a developer working in government, we really encourage you to join our community. And if you'd like to receive regular updates and help co-create OpenCRVS, you can go to the OpenCRVS website and enter your email details at the bottom and a brief mention of your interest, and we'll get back to you and make sure you're included and receive updates. Next slide, please, Anina. So in fact, I'm now going to hand over to Anina, who's going to run through some of the key product capabilities. Thank you.
Just unmuting there. Thanks very much, Ed. So we've had an introduction to OpenCRVS and why it exists and what it promises to deliver. And now we just want to share some of the key features, hopefully some of the things that will resonate with all of you in different countries, organizations around the world as problems that perhaps you experience and features that respond to those specific challenges that we've observed in civil registration systems around the world. The first and probably most frequently asked question is, does OpenCRVS work offline? And the answer is absolutely yes. We recognize that in many countries there are large areas either without connectivity or with low connectivity. So registration staff can work offline, and obviously at a point where information needs to be transmitted for processing by someone else, obviously it requires a connection, but that information can be sent as soon as that connection is made. Perhaps even more importantly, it works in low connectivity. And so what that means is you don't get that little spinner that you see spinning on your page for 10 minutes. It allows the user to continue to work and actually tells them exactly what the status is. So you can see on the right-hand side here of the screen, you know, that those applications which are being completed, they're being sent for review. You can see they're waiting to send or they're sending. So the user always knows at what status the application is at, so that they're not affected by a lack of connectivity. Another problem we often recognize is in countries where digital civil registration systems do exist, often they've been designed and developed only to work on one type of device. So that is, they operate on a PC or a laptop in an office environment. In countries where these offices aren't perhaps everywhere, or it's difficult and challenging for individuals to travel to those locations, we really want to take services to those communities. And so OpenCRVS works across any device. It can work on tablets, on mobile phones. This is also an opportunity for cost saving in countries where individuals have their own smartphones. Rather than managing a fleet of tablets or phones, you could actually have them use their own devices. That's just one option. It works across any type of device in any location. When introducing a digital product, one of the greatest challenges we often observe, and naturally, is people. And in many countries, the level of digital literacy varies. And so when introducing a new technology to people with low digital literacy, we really want to make this process as easy as possible. And often we've observed that registration agents, when provided with a new technology, they have difficulty completing these long forms in a digital format. So what we've done is we've tried to make this as easy as possible for end users. And we use question-led forms that guide the end user through the entire process while keeping form entry simple and easy. There's an example of this in the picture on the right-hand side. So we ask one question per page. Where did the death occur? And then provide multiple options for the user to collect. That not only guides the conversation that the user is having with the applicant, but it also makes that process super easy and as quick as possible. When thinking about costs, because this input process is easier, we can also think that training users in the use of this product is also easier. So you can save time and money there as well. Lots of discussion often happens around the fact that digital civil registration systems often operate in silos. So they don't actually realize their true value because they're not working with other e-government systems that really enhance their value. OpenCRVS, in response to this, is built using open standards that makes interoperability with other e-government systems super easy. We use what is called, for those technical people on the call, an HL7 FHIR standard. So that's an existing global health standard for the structure of the records and the database that we use within the product. So that means that OpenCRVS can work super easily with health systems, and national ID systems, a range of different systems. So for instance, in Bangladesh, we've integrated with their health system there that they use, DHIS2, and we can receive information very easily from health facilities with regards to births and deaths. Another example there is integrating with national ID. So reducing the effort required for end users by being able to not only verify that the individual in front of you is who they say they are by checking that national ID system, but also reducing the time and effort of the user in inputting that information, because you can auto-populate fields with that data. So it works really easily with other systems. Civil registration services and managing them across the country is another area that it can be really challenging. And often those responsible for civil registration don't have an accurate view of service levels and performance. So it's very difficult to know, what's working, what's not working, how do we hold people accountable? So in response to this, we really wanted to leverage the data that OpenCRVS is gathering and create real-time data visualizations. On the right-hand side, you can see some headline registration rates. So this is a view of the dashboard available in Bangladesh. So in Bangladesh, registration is required within 45 days of the event. So you could see here over time what those rates are, broken down by time period, but also really dig in at a national and a subnational level of what areas are performing well, what areas are not performing well. And even further to that, we've added operational data that supports performance management and targeted improvements. So you can see right down to an individual level how long people are taking to complete a form, how many applications are being submitted, what status they're waiting at. So you can really respond and ensure that services are being delivered in a good way. We all know that the value of civil registration systems, or one of the big values, is that they create an abundance of data. But often the challenge is governments aren't confident in the quality of data, and in large part, but that's because this is really a people business, and people will always have opportunities to conduct fraudulent activity. And often what we find is there are a large number of duplicate applications within databases. In response to this problem, potential duplicate applications and records are matched using an algorithm, using an existing very powerful tool called Elasticsearch. So Elasticsearch is actually an open source tool. It's used to power OneDrive, so Microsoft OneDrive, and it can identify about 500 it conducts about 500 deduplication queries per second. And what this does is, you can see on the right-hand side, it provides registration staff with the ability to first of all, potential duplicates are flagged, and then they can decide which application is a duplicate. They can review it, they can reject it, and they can manage the quality of data that is in the system. At a really human level, when talking to people within communities, when we were designing this system and working in civil registration systems for the past several years, often people visit offices without knowing the status of their application. So they'll go and they'll visit to collect their certificate, and unfortunately the certificate's not been signed because the registrar isn't there, or the application hasn't been processed. And after several unnecessary trips, they just give up on the process. So often the full application won't be registered, or they don't get the value of the certificate. So they really don't, they can't get the protection as a result of that. What OpenCRVS allows is status updates provided to the informants to set really clear service delivery expectations. So, we'll tell the user via SMS, although this could be delivered via other communication methods, depending on the country, what status their application is at, when they should visit the office, what they need to bring to make sure that that individual's experience is a really positive one. Wouldn't it be great at the end of the birth or death registration process that people thought, do you know what, I'd absolutely do that again. And finally, the question of language. Often system users, where digital systems do exist, they can be unfamiliar with the default language. So for instance, they might, if that default language is English, or an example you can see here on the right, we provide users with the opportunity to select whatever language they are most comfortable in operating in. So in Bangladesh, some agents prefer to input the information in English, and other agents prefer to use Bangla. And it's giving them this choice. In other countries like Zambia, there's over 70 languages. And we're not saying you'd have to translate all the content into those languages, but it does give the option to a country of what languages you want to make available to make sure that users can use the system as easily as possible. So those are just a few of the key features of OpenCRVS. As Ed said, you can explore more of these within the functional documentation. But now we'll talk a little bit more about the technology of OpenCRVS and how that can help you. Thanks.
Thank you, Anina. So just by way of getting into the sort of the technical approach and the technical architecture, I want to make sure it's clear that we have taken a technical approach which responds to, again, responds to user needs and what we heard from civil registration authorities as we were conducting our preliminary work. So if you go to the next slide, please, Anina. So there were a set of problems that we heard sort of time and time again from civil registrars around the world. And much like the previous section, a set of problems which have a process or a functional response within OpenCRVS. Some other problems have a more technical response where we can create a smart technology platform or solution to respond to these challenges. So what are those challenges? What do we hear? Well, we heard that countries were not able to take full advantage of the latest technologies because they were because they already invested in legacy systems. So they had existing systems and they didn't know how to move forwards onto the latest and greatest technologies. They also told us that the cybersecurity threats were increasing and they were worried about fraudulent activity and the misuse of personal data. They also told us that the civil registration systems can be really expensive to procure in the first place, deploy, but then actually over time to host and maintain them, the total cost of ownership can spiral and be really large. They then told us that with the existing systems, either proprietary or homegrown solutions, when they wanted to change the requirements and they wanted their system to be flexible, they found it really difficult and it was really costly to implement those changes. It also said that users found typical traditional CRVS systems, digital systems, really slow and not always available. And finally, there were problems to do with local technical resources, are really hard to find and even more difficult to keep, such that solutions which were implemented were really difficult to support with local resources. So this is a set of problems which we put to our technical team, and Ewan will now present the sort of the technical architecture solution which responds to these problems and much, much more. So I'll hand over to Ewan.
Thank you, Ed. So the technical architecture of OpenCRVS was designed to conform to the Open Health Information Exchange, OpenHIE, architectural standard, and HL7, Fast Healthcare Interoperability Resources, or FHIR. So as Anina mentioned, FHIR is a global standard application programming interface, or API, for exchanging electronic health records. By following the OpenHIE framework, OpenCRVS seamlessly connects civil registration to health services and other systems. Firstly, by utilizing the OpenHIE interoperability reference middleware, OpenHIM, a FHIR standard enterprise service bus, and secondly, by using a scalable, modular, NoSQL FHIR data store called Hearth. We use OpenHIM to receive birth and death notifications from the hospital setting or legacy systems and expose registration events to any other technical system, such as National ID or DHIS2 via an API gateway. OpenCRVS business functions are designed using modular, event-driven microservices. Each microservice and every OpenCRVS component is independently scalable in private or public cloud, in large or small data centers, and easy to manage, load balance, and network using included Docker Swarm configurations. OpenCRVS builds on these sound principles by additionally providing easy country configuration via simple text files, standards-based multi-language content management, our market-leading powerful search and deduplication engine powered by Elasticsearch, real-time performance analytics powered by the time series database Influx, increased performance by the use of GraphQL, reducing HTTP requests between client and server, an automated continuous integration, delivery, and testing suite, a progressive web application for offline and low connectivity access from a mobile device, external server and application health monitoring and automatic SSL configuration. So OpenCRVS provides a full stack designed for the lowest possible total cost of ownership and peace of mind, with the understanding that both the OpenCRVS application and infrastructure has been security tested by an independent CREST certified third party to UK government standards. Our international development teams work in an agile way in tandem with local development resources and human-centered designers, following the Scrum methodology to rapidly design, build, deploy, test, and maintain OpenCRVS instances anywhere in the world. So this concludes at a very high level the general technical approach of OpenCRVS. And if you have any questions, I would be really happy to answer them in the QA. So back to you, Ed.
Thank you very much, Ewan. Yeah, we're super proud of the technical and design teams that we have working with us on OpenCRVS, and I think you can understand why from that brief overview. We're really proud of the technical approach, but also in the fact that the donors who have supported us to get to this point have invested time and money in creating such a high quality solution, hopefully for as many countries as possible. So Anina, moving on to you to give an overview of some of the work you've been doing in country.
Yeah, absolutely. So as we've shown, the product responds to common problems. It's built on a super smart technology stack. And all of that comes together to really work for you and work for, you know, at the community level and with real users. So the two examples that we've spoken about, first of all, the pilot in Bangladesh. We're incredibly proud and excited to be working with the government of Bangladesh. I know that there's a number of representatives on the call of people who lead work there for civil registration. And really the purpose of the pilot in Bangladesh was to develop a future model for birth and death registration that will help the government achieve their aim of drastically increasing, well, achieving universal birth registration and close to universal death registration within 45 days by 2025. The modality of this, to bring it to life in Bangladesh, what does this mean? Well, first of all, it means taking services to the community level. So completing applications at the community level with community health assistants. You can see our friend Shami, the community health assistant in the picture on the right, holding the OpenCRVS, a tablet that's provided by the Ministry of Health in Bangladesh, but used at the community level to complete applications at people's homes. And this really did receive incredibly positive feedback, not only from the health workers who are really excited about the opportunity to build on and improve their digital literacy, but those applicants, those mothers and fathers, and those unfortunately who have lost people at the community level receiving that service on their doorstep, they were just simply delighted to only have to visit the office on one occasion. Another modality, as Ed mentioned earlier, and as the technology stack allows, is receiving birth and death notifications from a health system. So in Bangladesh, we've integrated with DHIS2. So why is that important? Well, it allows us to leverage existing services. So not asking health workers in hospitals to do anything other than what they're already doing, and to start a birth and death notification, triggering that from information that's already gathered, sending that to OpenCRVS, and then handing over to registration staff to complete that process and to ensure that people get their birth and death certificates. And the purpose, obviously, of this pilot is really to learn. So working with all the stakeholders within Bangladesh to test out these different models, what works, what doesn't, make sure we're learning, make sure we're iterating. So by the end of this year, we can share an investment case with the government there to say, you know, these are the things that worked really well. Here are the results to show, you know, what's contributing to increased birth and death registration rates, which modalities work in different contexts. So just to bring this to life, you can see a health assistant here in rural Bangladesh in the north in Burungamari, where we're working. Here you can see the registration agent with our colleague Shahidul from the Cabinet Division, showing him how he's using OpenCRVS in an office environment. And we're also exploring different users. So here's a village police officer who might be part of the process notifying deaths. So another country, like we've said, where we've configured the product is in Zambia. And what's important to mention here is, you know, the ministerial meeting wanted to demonstrate OpenCRVS for the African context. So within a period of 3 months, we were able to conduct research at the community level and facility and office level in Zambia, understand the requirements, configure the product for the Zambian context. So make sure that the forms were ready, make sure that the services fit the needs of Zambia. So there, similar to Bangladesh, a community-based application was used, but actually in Zambia, health workers often had smartphones, so they used their own devices. Health-based applications as well, so making sure that applications could be completed within health facilities, and then registration authorities validating and issuing the certificates. We also tested this with a number of users. So here you can see we tested with a mobile operator offering the service within the community, which worked really well. Here again, at a service point, and here's a system administrator managing kind of teams in an office environment. Hopefully that brings to life a little bit of OpenCRVS working for real people, and that's what this is really all about. And it can be configured incredibly quickly for each country context. Over to you, Ed.
Thank you. You'll be pleased to know this is the last section, and I imagine you're a little overwhelmed with some of the information which we're sharing, but we felt it was important to finish up with a few pointers on implementation of OpenCRVS, and I can see some of the questions coming in the chat, which we'll try and get to relate to this. So in terms of implementation, what we have learned thus far is, you know, we would recommend a sort of 3-stage approach, very much in line with the work which we did in Zambia. Point 1 would be to conduct what we call a rapid in-country feasibility test. So this could be done, you know, potentially within 3 to 4 months. And the purpose really is to gather a minimal set of country requirements. So not, you know, without getting a full set of requirements and taking months in terms of doing that design work. We do a minimal set of country requirements, configure OpenCRVS, you know, as best we can for that country context, and conduct a small scale pilot and see it working in the field. So this is for 2 primary reasons. We do this in a short period of time, also for a small cost. Would be because we want to see OpenCRVS working in the field. We want to get users hands-on, gathering their feedback, so we can gather that, so we can put that into design for a full configuration. But the second reason was really important. In the early phases of deciding upon a digital civil registration system, we understand it's really key to get buy-in from key stakeholders, potentially from the Ministry of Finance or those with budget to spend on civil registration, to actually see and bring to life OpenCRVS within that country context, configured for that context, working and seeing people respond to it, we feel is really important. So we would typically run a conference room pilot or something like that to get the buy-in from senior stakeholders. So the output of that 3 to 4 months would be an initial design, a working but cloud-hosted solution, so not locally hosted, hosted in a public cloud, and at the end of which would be a business case for scale and to take that forwards. So the second phase, if the feasibility test proves positive and OpenCRVS seems to respond to the needs of the country, then we'd invest more time and effort and actually start preparing for scale. So obviously this is a longer period of time, 6 to 9 months, for example, which would result in a locally deployed and integrated OpenCRVS system. So this would allow us to test OpenCRVS in many different contexts over a longer period of time, rural and urban locations, within hospitals, integration with health systems, also operating at the community and office level. So each part of the process, we'd see the full configuration working and being fully tested. We propose that it's also, by that point, integrated with health systems and national ID systems. So Anina mentioned in Bangladesh, OpenCRVS integrates with DHIS2, and we know that DHIS2 is widespread across many parts of the world, etc. So we've proven that integration point, and OpenCRVS would interoperate with other health systems as well, obviously. And the final part of that, really important, because it's not just about the technology alone. So the rollout planning and the testing of that is very important within this phase. So working on the training materials, the change management, how to change roles over time and make sure people are fully supported in the changes of business processes, etc. And setting up a service management function to maintain and operate the solution once deployed. So the outputs of that longer phase would be a finalized design, which can then scale, a locally deployed solution, and a deployment strategy and plan ready for point 3, deploying at scale. And obviously timeframes are very much country dependent, depending on the size of the population and the different sort of geographic settings. So that's the end of the formal presentation. We'd love to open this up now to questions. I think we should probably honor those questions which have come in from the Zoom chat, but continue writing your questions. Now we've got to the end of the presentation. I will just zoom back a little bit to see if I can see these, and we'll start working through them.
Yeah, perhaps I can help there. So Ed, the first question comes from Hassan Sheikh Ahmed. How the OpenCRVS documents are aligned with WHO tools for birth and death registration?
Yeah, great question. So I think there, in 2 ways, we worked with WHO. We had early involvement of WHO on the technical advisory group, helping inform what minimal amounts of data should be captured in birth and death registration forms and applications. But I think most critically and operationally, the fact that we've invested time in interoperability between OpenCRVS and health systems through open standards, as Ewan mentioned, through the HL7 FHIR standard. That's really the main reflection in terms of how OpenCRVS can work together in tandem with health tools for capturing birth and death notification within health facilities and hospitals. And the answer really is through sharing data through the interoperability layer. I'd probably just at this point like to call out our friends from our partner Genby Health Systems, who were instrumental in helping us think through how we should create the interoperability layer and the use of Open HIE and OpenHIM, for example.
Brilliant, thanks Ed. The next question comes from Chesno at Digitech. Can we set up specific rules, country laws, like the time between declaration and certificate production? So that's really, I think, a question around kind of configuration requirements, to which I think the simple response is yes. Like Ed, like we've said throughout, kind of the product is highly configurable. So you can change the requirements of those kind of standard workflows as per country requirements and country laws.
Maybe just a point on configuration. So we've tried to create OpenCRVS as a configurable product. And what does that mean? It means that we've tried to build in sufficient understanding of variability of contexts to allow easy configuration of the product. There will be some country-specific requirements, of course, which may require full customization. There's something which only happens in one particular country context that may require customization on top of the configuration.
Great, thank you. The next question, forgive me, I think I missed it, was actually the first one. It was how OpenCRVS piloting will be completed during COVID-19 pandemic in Bangladesh. So I'll briefly touch on that. Naturally, following government rules and regulations related to the holiday that was enforced. So certain offices obviously have been closed, and so activities have stopped, but community health assistants are still working at the community level. So we are working to see what information is feasible to be captured during this period of time, both through the community health assistants who are continuing to work, although we are finding that their workload obviously is increasing. So the focus on civil registration activities is less, but also testing out other modalities. So could, for instance, we start notifications at the community level, and could someone more central complete application forms? None of this is happening at scale, but we are exploring what modalities might be able to work, and we're going to feed that back to the Cabinet Division Office of the Registrar General to decide whether that's something that could be feasible at scale.
So next question, I've got this next word, Adila. So, well, it's for you, I think, but how are you linking the CRVS to national ID systems in Bangladesh?
Absolutely. Well, I can talk about the functionality, and if more technical response is required, please do let me know. There is an existing service within Bangladesh that allows any organization to verify the validity of a national ID and the number that is provided. So we have integrated with that service. What that service also provides is the ability to pull certain bits of data associated with that national ID, and it actually auto-populates certain fields within the application form to reduce the time required on the individual entering that information. So we actually use an existing service that's available in Bangladesh. Now we are about to embark on a piece of work that is looking at integration with national IDs more generally, and looking at developing a standard with our partners at Dial and Digital Square. So that work is coming, but all obviously working towards standards-based approach to integration with national ID.
Yeah, just a big shout out to the team from MOSIP who are supporting us. That's the triple ITB in Bangalore who are behind the MOSIP platform, who are helping us define open standards for how civil registration systems like OpenCRVS can be interoperable with national ID. The next question is about principles. Does OpenCRVS follow the ID for D, Identity for Development principles? So the short answer is yes. It's very timely, the fact that those principles have been written and give great guidance of what well, ID and legal identity systems, how they need to be built and how they need to support countries. But in addition, and what we didn't mention was that very much we were inspired by the principles for digital development in the way that we have developed OpenCRVS, and those who know those principles very well hopefully will see some of the themes coming through in the way which we have described OpenCRVS. Maybe last question or two, Nina?
Yes, absolutely. There's several, sorry. On the tech, some country pushes for local servers citing data security, etc., no matter how robust the system is. How have you handled such requests? So I think this is really about the capacity to be able to manage either local infrastructure or alternatives.
Yeah, it's a great question. I believe Ewan mentioned in his view of the technical architecture that OpenCRVS can be hosted in a private or public cloud. There may be advantages in from a total cost of ownership perspective for OpenCRVS to be hosted outside of a jurisdiction and even together with the infrastructure for other countries to get some economies of scale. But obviously, this is a this is a question for the country itself. A country may feel, and its laws may prevent that they prefer to have their data residing locally. On that point, I think it's really great that some countries are now exploring whether that is indeed the safest and most secure place for data to reside. I think that will continue to develop over time.
But it is possible to host it locally, and we have configuration in that local installation process that encrypts the entire database at rest, and our processes will seamlessly combine with any organization operating ISO 27001 standards to ensure safety of that data locally.
Thank you, Ewan, for chipping in. So in the interest of time, I think our time is up. I'd just like to go to the last slide. And before I do, I mentioned GenB Health Systems, one of our core partners. I'd like to also call out our friends at Vital Strategies, Bloomberg Data for Health, and our donors from Australian Aid, Dial, and Digital Square, who've all been tremendously supportive of the vision we had for OpenCRVS. And it's great that it's now coming to fruition. So thank you so much to them, and obviously to you for joining this call. I just want to leave you with the links which we shared earlier. So for more information, do go to the code repository if you're of a technical bent. If you want to see the documentation, please go and see that, or the general information obviously is held on the website, all the links here on this page. If you want to reach out for any other purpose, I could see there's a number of additional questions, which is fantastic. And thanks so much for the positive response and the work which we've been doing. It wouldn't have been possible, without your support and help and encouragement along the way. So please reach out to me or another member of the team through the website. And we are recording all of the questions, and we'll find a way of getting back to you either by responding to questions, frequently asked questions on the website, or directly by mail. So thank you very much for joining us today. Thanks for your time and interest in OpenCRVS. I hope to speak to you all very soon. Stay safe in these difficult times.